I'm going to tell you a little bit about native web animation, so animation without libraries. My name is Lisi. I'm at Lisi Linhart on Twitter, and lisilinhart.info is my website if you want to check it out. This talk used to be a 3-hour workshop, so I cut it down to different topics. So what we're going to do is we're going to do it a little bit interactive. I have 4 different topics, which is CSS transitions and CSS animation, performance, well, that disappeared, CSS custom properties, and the web animations API. And we're gonna pick 2. So I'm gonna ask you to raise your hands. You can raise your hands twice for 2 topics you're interested in. And then the one with the most interest we're gonna do, because we can't do it all. But you can come to me afterwards and I can tell you more about everything you wanna know. All right, so if you wanna hear something about CSS transitions and CSS animations, that's 1. Raise your hands. All right. If you wanna hear something about animation performance, okay, that's 1 more. CSS custom properties. All right, that's similar to the first one. And the web animations API. All right. So I think it was performance and the web animations API. So I'm gonna just skip through these. All right, that was too far. All right, so we're gonna start with performance. When we do animation, the most important property to use is the transform property. There's 4 things the browser can really animate really cheaply, and that's position, scale, rotation, and opacity. And so position, scale, rotation, you can do them all with CSS transforms. And opacity is just CSS opacity. Yeah, and you use them in CSS with the transform property mostly. The transform property can do a lot of things. You can translate things, so you can move them left to right, up and down on the X, Y axis, and also in the 3D space with translate set. You can rotate things on different axes, on the Z axis, on the X axis, and the Y axis, so you can also do 3D rotates. You can scale things up and down, then you can skew things, and yeah, you can also rotate on different axes. CSS reference is really useful, the link on the bottom, to like look at what transform can do and how to use the different properties. Because some of them use degrees, some just use numbers between 0 and 1, some use pixels, so it's all different depending on what you're using. And in combination with transform, the transform origin is really important. It tells your animation from which point it should start. So if it should origin from the center, from the top left, from the bottom right, it looks like the following. So if it's from the center, it's gonna transform like that. Then you can also have it outside of your object. So you can rotate, for example, around a circle, or you could just have it on the top left or on the bottom right, wherever you need it to origin from. So what happens when we change something? This is really important to know, to realize how does the browser paint a website, what changes you can make and how they influence the painting. So first your JavaScript is evaluated. Then the browser is gonna recalculate your styles. He's gonna see how much space does every element need, where does it go. This is often when you do left or right or top or bottom with CSS. Also the layout calculations, it's the same step. Then we have the painting, so everything gets rasterized and put onto layers. So you have different layers when your browser paints something. And you can move layers independently. So if you have a layer in the bottom, you can move it independently from another layer. But your browser is gonna group things together into layers, so you don't get too many layers, because too many layers are also unperformant. And in the end, we have the composite step, and that's where the browser takes advantage of the GPU, and all the layers get glued together to one frame, and that's what's shown to the user. That happens in the last step. So all of this happens in one frame, and so when we change different things, it's gonna influence our performance. So when we change layout, it's gonna be in the layout step. So in the second step, this is when we change the width, the margin, the left, the top, all of these layout properties. And that's really unperformant, because then the browser needs to go to also through the other steps after that. And that's why you don't really want to animate layout properties, because yeah, it's going to be unperformant. Then we have the paint step. That's when we change, for example, the background color, shadows, outlines. It's more performant than layout, but the most performant way to animate is, like I already said, the transform property, and that's happening on the composite layer. So transform and opacity are the last step, and then when you animate those, you don't need to go through the previous steps the browser needs to run through. Yeah, so try to animate always on the composite step. This is what it looks like in your DevTool, so you can debug animations and see what's happening, what's causing your animation to be slow, where the issues are. Yeah, and the coloring, you can also look at why it's taking so long. Also, yeah, like I already said, a lot of layers are bad, but it's good to like create layers for the right things. So if you animate something specifically and you know you're gonna need an extra layer for that, it's good to create layers. So what creates a new layer? A 3D transform always creates a new layer. So if you use Translat C, Z, or yeah, any kind of 3D transform. Animated 2D transforms do also create layers. So if you have keyframes, you animate transforms, you're gonna have those on a separate layer. Being on top of compositing layers also creates a new layer. So you have to see where your layers are, and you should rather animate on the top layers, not on the bottom layers. Accelerated CSS filters create new layers, and of course the will change property creates a new layer. That's the most popular one, but you have to be aware when you create new layers that every layer consumes memory. So yeah, only use them when you need them for animation, and maybe remove them when something has stopped animating. So this is sus mixing for like really making sure that a new layer is created. It uses will change, then it uses transform translate set, because will change isn't supported in all browsers. So if you really want to support all browsers, you're gonna probably use a 3D transform. Yeah, and on will change, because you always create new layers with will change, you shouldn't optimize all the elements, because you're gonna get a lot of layers and you don't want that. And only use it if the change happens constantly, and maybe remove it when you don't need it anymore. And yeah, in some browsers it's not supported yet, so you're gonna need to use the 3D transforms. Also, another thing for performance that's really important is a function that's called requestAnimation in JavaScript. It's a function that the browser can optimize so your animations will be smoother. It will stop when you're in another tab, and it allows the CPU to chill if you go to another website, so it doesn't run consistently if you're not even looking at it. And it's more battery friendly. So if you do consistent changes, consistent animations, requestAnimation is a great way to make it more performant. And you don't need to use it if you're using the Web Animations API, because it does this automatically. Yeah, and GreenSock, of course, also uses the requestAnimation already. And you can use the cancelAnimation function to end calling the requestAnimation function. This is what it looks like. So it's a function, and then you do your changes, and in the end, you call this function again. And you start calling the requestAnimation function by calling requestAnimation on your function with your changes that should happen on every frame. So to summarize this, if you want to get performant animation, you should only animate transform and opacity if possible. Use will change and requestAnimation where you need them. Don't create too many layers. Look at what layers you are creating and animate elements on the top layers. And also inspect and test your animations in the DevTools. That's really important. And I can show you later, if someone is interested, how to use the DevTools to inspect your animations. All right, that's the performance part. Let's see, let's go, all right, to the Web Animations API. So the Web Animations API tries to combine the advantages of CSS animation and performance like hardware acceleration with JavaScript. So you animate completely in JavaScript, but you have a lot of the advantages you have in CSS. Yeah, you animate completely in JavaScript. You have more control over your animations. So doing timelines in CSS is kind of hard if you have like more than 3 staggered animations to deal with. So the Web Animations API tries to make this easier, and you can also pause and make your animations faster. It's really good for like dynamic and reactive animation. So when you have like mouse movements and other more dynamic things you want to react to. And you can really combine it nicely with JavaScript events, because you do everything in JavaScript. You can use it in your frameworks, in Vue, in React, wherever you need it. And yeah, you get controls and callbacks. So this means when an animation is finished, you get a callback, and you can pause it, replay it, whatever. And you can do grouping and timing. So how does it look like? The Web Animations API, to call it, you have a function on a DOM element. So every DOM element, if you do document query selector, you can call on this DOM element the .animate function, and it has 2 values. So the keyframes object or a keyframes array. This is the stages of the different animations, so where you start and where you end and how your animation behaves. And then the second part is the timings object. It's how it's animated, so how fast it is, how much delay it has, and other timing related things. All right, so the first part, the keyframes, you can either use an object or an array. If you use an object, you have the CSS property and then give it all the values you want to animate. And if you have an array, you have an array of objects, and that's the different parts, the different frames of your animation. So that's for the first part of the function. For the second part of a function, you have a timing object. It has the duration, how often you would run the animation, if you run it forwards or backwards, if you want it to go forwards and back, the delay, the end delay, and the easing. So you can use, all of these are really similar to CSS animation, so you can use the CSS easings you're used to, you can use cubic Béziers, and also the direction and the fill are what you use in CSS animation. So to call it, you would get an object, and then you would call .animate on this object. You'd have the keyframes and the timings. So for example, this would do, my object would be scaled to 0 and not visible. And then there's like 0%, and then at 100% it would be scaled to 1 and visible. So it would fade and scale in. And then it would take 2 seconds. I have an easing, I would run it once. And the fill forwards is the fill mode. This means after the animation is finished, it's gonna stay the way it was animated to and not go back to what it was before. Then once you have an animation, so once you call this function, you get back an animation object. And you can do different things with this animation object. So you could get the play state in the second line, if you just played it, it's going to be running. You can pause your animation, you can play your animation, you can cancel it, so make it go away. You can jump to the end of the animation, or you could play it backwards, and you could make it faster or slower depending on how fast your playback rate is. And you also get callbacks. All right, it's not working. You also get callbacks, so also on an animation object you get callback functions, so you can say animation on finish, do something, or when my animation is cancelled, remove my whole DOM object because I don't need it anymore because the animation is done. All right. This is a little animation I built with the WAAPI API, and I'm going to explain it to you. So this is the keyframes, and then the offset. On every keyframe, I can define an offset, and that's similar to the percentages in CSS animation. So offset 0.33 would be 33%. So I can have different parts where I want to animate my properties. Then I have a timing object, and then I just call on my DOM object, I call my animation. And now what I can do is my tree is one DOM element, and I can add an event listener, and then I can take my animation object and I can set the current time, which is the time of the animation of the apple, to 0. So it starts from the beginning, and then I replay it. So I change the properties. I can also add an event listener to the apple and make it faster. Here in the bottom you see that that's the playback rate. So now the animation is a lot faster. So I can really like dynamically change how my animation behaves in the browser. Yeah, this is, I think it's too small, but this is an example I did in the workshop. And here I'm just staggering different elements after another, and then I can just stop the animation, restart it, and it's all just here in the JavaScript, the different keyframes. You can look at it later in CodePen and play around with it. All right, a little bit about the WAAPI API and CSS. So what's the difference? When should I use the WAAPI API? When should I use CSS animation, maybe? Well, CSS is great for styling and for static animations. So if you have some predefined animations, CSS is really enough. But if you want to like interact with the animation, if you want to react to some JavaScript events, if you want to react to something the user does, the WAAPI API might be a better option because yeah, you can change all the things right there. Also transitions and hover and focus animations, so maybe buttons or loading spinners, they can all be defined in CSS because they don't really need to be that reactive. And CSS also is really simple and declarative, so you don't need to know like really a lot of JavaScript to do a CSS animation. So if you want really simple animations, CSS is enough. And what's cool about CSS is also that you don't have JavaScript blocking. So if you run a lot of JavaScript and you have all your animations in like a JavaScript animation library, it can be that your animations are not running because all your JavaScript is reevaluating. And if you do CSS animations, you won't have that problem. The WAAPI API is great for sequencing because it's built for doing more complex animation. You get controls, callbacks. You also get all your animations in your document timeline. So you can get all the animations you have defined in your document, and you can stop them all or replay them all, or for accessibility, make them slower or make them not play at all. You also get hardware acceleration like you get in CSS. And yeah, it's going to be natively in your browser in the future. So all the browsers are already working on implementing it. So it's going to be a more advanced option on doing animation in the browser. And yeah, the web animation API to libraries, when you should use the web animation API versus like a big library like GSAP. Well, the web animation API is going to be native, so you won't need to load anything in your browser, versus a library can be kind of big. It depends on which animation library you use, but you're going to have an external dependency and you're going to need to load it. So the size, you don't have any additional size in the web animation API. If you do SVG animation, which is very popular, it's going to be hard to do with the Web Animations API because there's a lot of cross-browser inconsistencies in SVG. And what a library like GSAP does, it's like a big SVG animation polyfill. It solves all these issues, and that's why when you animate SVG, you normally choose an animation tool like GSAP or another SVG animation library. Browser rendering. So when you use the Web Animation API, the browser optimizes it because you're using the browser API, so the browser knows what you're animating. When you use a library, often the browser doesn't know that you're animating these elements, and so it can't optimize for this animation. And yeah, it's going to be small because it's going to be native. This is also interesting. This is different libraries, animations, without JavaScript blocking. And if you add JavaScript blocking, all the JavaScript libraries, they're going to be like slower. And if you have a lot of JavaScript and it's unperformant, then your animations are also not going to run smooth. So with the Web Animations API and CSS animations, you don't have that problem because you're using in-browser optimization. The problem about the Web Animations API is, of course, the browser support still. It's in implementation. There's a really good polyfill on GitHub, and you can use it, and then it's like an animation library you're using. It's going to fall back to the native implementation if it's there. If it's not there, you're going to load the polyfill, and you can use all the Web Animation API things already on production sites. And the web platform tests you can look at to see how far the implementations are. So you can look at the different parts of the animation and see which browser already implemented which functions. That's why Can I Use isn't really saying that much, because different browsers already implemented different parts of the API, and you don't know if you just look at Can I Use, it doesn't mean they haven't implemented it at all, but they're still working on it. They just haven't implemented everything. And JSUnconf is a really small animation library that uses the Web Animation API under the hood. So it's really tiny and it's really easy to use. So you don't have to write so many keyframes, and you get like easings and different stuff. These are some examples I built with the Web Animation API. So you get all this like interaction. You can reset your animations, and then I can change the text in the back on a callback. So I get to like react to what the user does. This is with a slider. So you have a slider, and then you start some animations. So dynamic reactions to what the user does. So that's where it's going to be hard to do in CSS, and that's where you would use the Web Animation API. All right. One more thing I wanted to say. If you do web animations and you want to make your animations look better, try to level up your easings. Don't just use ease in, ease out, but look at different easings. There's a lot of tools like easings.net. So you get all these different easings in CSS, and you can just copy them. also here in the bottom, there are some easings which you can't do in CSS. That's what like CSS animation libraries do, because you can only have like a simple curve in CSS. In JavaScript, you can do like bouncing easings, which are really great for more dynamic animations. Then Cubic Bezier from Lea Verrou, it's just great to play around to see how your easing looks like, and it has like in the top, you can compare different animations and different easings. And what I also love is a great tool is GSAP and GreenCirc's Ease Visualizer, which is really great because they have a lot of like more complex easings, and you can, in the bottom, you can change them, make them faster and slower. And when you get started with animation, this is really useful to try different easings and play around with how your animations behave. There's also just predefined easings in SAS, or there's a great Medium article called Crafting Easing Curves for User Interfaces, which goes more in depth into easings for user interfaces. All right, that was it. I hope you enjoyed it. The slides will be at slides.com. This is Linhart JSUnconf. So you can look through everything. You can look at the examples on CodePen and play around with them. And there's also the other parts, which I didn't have the time to go through. They're also in these slides. So you can also look at the other parts we didn't cover. Yeah, that's it. Thank you.